Hey guys, Mr. Blue here with another high quality chemistry video. Alright, let's get going today on talking about the formation of ions in a little bit more complex of a sense. Right, so let's start with over here on the periodic table, for instance. Let's go with magnesium here today, okay? So what we have, right, is let's draw out magnesium quickly. So magnesium is going to have 12 protons. Its atomic number is 12. 24 is its weight, so it's going to have 12 neutrons. Who cares? Right, today we're talking all about electrons. So here we go, okay, we're going to need 3 shells here today. And the capacity of that first shell, actually, let's do this as our valence shell. Okay, the capacity of that first shell is 2. So let's put them in. 1, 2. And then here, the next one is 8. So sweet, that's good. Now we've got 2 plus 8 is 10, which means we've got 2 in the outer shell. So what this means is my valence shell has 2 electrons in it. My outermost shell has 2 electrons in it. So what that means is that magnesium is going to get rid of those electrons. Now, hopefully at this point you're starting to see maybe a bit of a trend, and that is generally metals like to lose electrons, and generally non-metals like to gain electrons. And what happens is metals will lose them, and they will become cations, and non-metals who gain them will become anions. Okay, so these electrons, they get spat off, okay? So where are they going to go? They're going to get accepted over here by non-metals that like to gain them. And then we're going to get the formation of a metal plus a non-metal is going to make an ionic bond or a salt. Now, I don't want to write this out, okay? I just want to abbreviate it. So there's my magnesium, and there's my 2 electrons on the magnesium for this ionic bond. Now, what's going to happen here, okay, is that let's maybe look over here on this side, and let's look at some fluorine again. So if I go back to my periodic table, let's check fluorine. Fluorine's over here, element number 9, right, which means it has 9 protons. It's going to have 10 neutrons, and then it's going to have 9 electrons as well. So here's my fluorine, 9, 10 protons, neutrons. Now, okay, no, I want that to be red. So where's my blue? There it is. Okay, so we're going to have our innermost shell has just the 2. And then with fluorine, we only need a second shell. Okay, just the P shell. And let's add our electrons in, so 9. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So fluorine, okay, its valence shell there has 1, 2, 3, 4, 5, 6, 7. So it wants to accept those electrons, okay? Now here's what happens, right, is basically we've got that valence shell, it's got 7. Magnesium here wants to give away 2. So even if it gives away its electron, okay, it likes to lose the electron or give them away, then what you'll see, okay, is it doesn't matter. We move that one over there, and the magnesium is still really, really, really unstable, okay? Now what that means is that we basically need something to solve this. We need some sort of different strategy to solve this. And it's actually quite simple. What we get is we just add another fluorine. Fluorine comes to the party, another one comes to the party, and what magnesium does is it gives one of those electrons to each of them. Now what happens, right, is both of those accept it, and the magnesium becomes 2 positive charges because it had 12 protons, but it lost the 2 electrons, so it's only got 10 now. So it's got two more positives than it does negatives. Magnesium 2+. Now the fluorines have accepted it. Okay, and we get the formation of an ion and what we call an ionic bond. Okay? Now, how this would look like is magnesium, fluorine, and fluorine, right? And simply put, we abbreviate that as MgFl1, 2, Fl2. So this is ionic bonds, once again, made a little bit more simple. Let's look at another example. Okay, this time I'm going to skip straight to the Lewis electron dot diagrams because they're so much easier. Okay, now this time, for instance, let's look at sodium. Let's get a look at the sodium. Now, sodium, okay, like everything in this outer down in this alkali metals, is got one electron in its outer shell. So you can see that as I move down, it's all got one in that bottom row, one in its outer shell. So that means that the valence shell of all of those things there is a 1. Now let's say, for instance, we're going to react our sodium with oxygen. Very common reaction when sodium is taken out of its wax container. Now oxygen, on the other hand, is going to have 6 in its outer shell. Okay, 1, 2, 3, 4, 5, 6. So there it is, 6 in its outer shell. So what we need to do here is, well, the sodium can give away, it likes to lose its electron, so it could give away that electron to that one there, to the oxygen, but that's not going to help out either of them because the sodium still wants one more. Sorry, the oxygen still wants one more. Okay, so what's going to happen is, again, the sodium brings a friend. And this is where we get our ratios coming in, is it needs twice as much sodium to make one oxygen happy. So what's going to happen is those electrons are going to move over and we're going to get those electrons move to here. And then what we're going to end up with is well, these guys lost one electron, so they're going to become positive. And the oxygen gained 2 electrons, so it's going to become 2 minus. So what happens now is the charges are equal, and I have a lovely chemical formula for sodium oxide. The formation of an ionic bond is this, and what we call this that's left over is we call it a salt. A metal and a non-metal together, a metal and a non-metal together is called a salt. Thank you very much. Another short lesson by Mr. Blue.